we're from ChemPraxis, and today we'll be discussing Chemistry Paper 5, Variant 2, February-March 2023. We'll be investigating the solubility of ammonium chloride in water at different temperatures. First, fill a burette with some distilled water. Using the burette, add 8 ml of distilled water to a boiling tube containing 5.25 grams of ammonium chloride. Clamp the boiling tube at an angle and heat the bottom of the tube while stirring the contents with a thermometer. Once all the solids are dissolved, continue to stir it with the thermometer while it cools. As soon as the solution becomes cloudy and a solid starts to form, record down the temperature of the solution. Using the burette, add 0.5 ml of distilled water into the same mixture in the boiling tube. Just like in step 3, heat the mixture while stirring it with a thermometer. Once the solids are dissolved, continue to stir it with a thermometer while it cools. Once the solution becomes cloudy, record down the temperature of the solution. Repeat step 4 to 5 3 times while adding another 0.5 ml of distilled water each time. Throughout our experiment, we can see that the more distilled water used, the lower the temperature when the solid starts to form. Using our results, we'll be able to create a graph. And for question C, when a total volume of 10.5 ml is used, we can use the graph to predict that the temperature when the solid starts to form is around 43 degrees Celsius. Using the equation provided, our mass of solid dissolved is 5.25 grams as it is constant throughout the whole experiment. The volume of water used will be 8 ml as it is the starting amount for the first experiment. We'll note that the solubility of ammonium chloride in the first experiment is 65.6 grams or 100 ml of water. Using a burette instead of a pipette can be an advantage as it will provide a more accurate result. However, If compared with a pipette, a burette has more specific readings in measuring, and hence we can measure variable volumes. In this experiment, we'll be finding out what is within solution C and solution D. In this flame test on solution C, we can see that bright green streaks of flame can be seen. After dividing solution C into 3 approximately equal portions of solution C, add aqueous sodium hydroxide in excess into one of the portions. We can see that white precipitate is formed, and in excess, it will dissolve into a colorless solution. Using the solution created in question 2b, add a piece of aluminum foil into the test tube and warm the mixture. While testing for any gas, we can see bubbles and the damp red litmus paper turn blue. These indicate that ammonia is present. Add around a 1 cm depth of dilute nitric acid followed by a few drops of aqueous silver nitrate into solution C. We can see that no change can be observed. Add around a 1 cm depth of aqueous sodium carbonate into solution C. We can see that white precipitate is formed. Throughout our experiment, we can see that zinc and nitrate can be found in solution C. After dividing solution D into 3 approximately equal portions, test the pH of solution D. We can see that the pH of solution D is around 1 to 3. Add about 1 cm depth of dilute nitric acid followed by a few drops of aqueous barium nitrate. We can observe that white precipitate is formed. Add a spatula of solid sodium carbonate and test for any gas produced. Fizzing can be observed and the lime water turns milky. Throughout our experiment, we can observe that hydrogen and sulfate is within solution D.